Okay, so we are going to start with our beginning of our new unit, which is actually a little bit of our old unit, but it's sort of pulling all of it together. So we are going to look at the quadratic formula today. And we're not going to do the quadratic formula in sense of Algebra 1. We're going to do a little more analysis with it, okay? So the first thing we need to do is standard form is when you have ax squared plus bx plus c, okay, equals 0. And we are solving for x, okay? To solve for x, okay? That means that your answer is x equals. That's what it means. X equals. Notice that the directions could say factor or solve. Half your questions said factor on the test, half of them said solve. Solving is when you do x equals. So given this standard form, the solution is opposite b plus or minus the square root b squared minus 4ac all over 2a. Okay, that's your quadratic formula. That is one way to actually solve a quadratic equation. Not isolating, not factoring, not complete the square. Quadratic formula. It's plug and chug. Thus, we have a calculator today. Okay? Because we're not focusing on the plug and chug. We're focusing on what we can learn from the quadratic formula, not actually doing the quadratic formula. Okay? Now, I am going to write this in a separate way because notice how there's two pieces in the numerator, and so I'm going to separate them and I'm going to write them like this instead. Because as you simplify, it might be easier to write them separate, it might be easier to write them together. All right. Now, the discriminant, okay, is another vocab word today. Okay. Okay, discriminant. Okay. It's related to the quadratic formula. It's the number under the radical, right? The number under the radical. So usually I use the letter D for discriminant. The discriminant is just the b squared minus 4ac number. Notice that there's no radical. Okay, it's the number that is under the radical. Okay. One more set of vocab words. Solution, roots, zeros, all the same thing, right? So when I say solve, okay, those are solutions, roots, or zeros, okay? There's one more word that I get to add here. And this is the word that really connects us to the next unit. X-intercept. X-intercepts are a visual of zeros, roots, or solutions. Okay? This is visual of solutions. Okay, because it's on the graph. X-intercepts are on a graph. On the graph. You're like, well, the graph of what? Okay, well, notice up here where we had standard form and the other side was 0. That means that on an axis, okay, there's no labels here, no labels, just axes. I'm going to draw a parabola, which is a U shape. Okay. And the x-intercept is the visual on the graph. This and this. It's a visual interpretation of the solution, roots, or zeros. Okay? Today, we're mostly going to focus on the yellow part. As we move through the unit, we're going to start talking about that pink part. Okay? Okay, so here is your worksheet. I want you to go ahead and find the staples in the top right corner, and we're starting with this equation right here, x squared minus 6x plus 9. Okay, so solve the following equations using an appropriate method. You may use the calculator. Note the discriminant in the box with the equation. So you are going to record what the discriminant is, all right? Now, you have to pick a method. Can I isolate? No. Can I factor? Maybe. So try factoring. So yes, you can use some of the other boxes, especially if you don't need that space. So can I multiply to 9 and add to, yes. Okay, so I'm going to factor. Right, and we are solving. Notice this is equal to 0. Okay, so x minus 3 equals 0. Okay, I know that there's not a lot of space, so if you need to do some scratch work on like the whiteboard or paper, then do that. Or if you need to leave out just a little bit, you can do that. Okay, so I get x equals 3 and 3. Okay, I would not complete the square if one of these other two methods work, right? You should only be doing it once in these first 3 columns. One of those methods should work. I would always start with isolating and work my way down. Yes?
So would you have to write 3 comma 3 or just do 3?
Okay, so you could just write x equals 3. Both of them would be accepted. I know in Delta Math sometimes they showed typing the answer more than once just because I got the answer more than once. But writing it once is okay.
Why can't you just do the square? Is it just because if that...
Oh, you can, but why would you if you don't need to?
That you only choose one of the methods and you go left.
Yes.
So if it works, you just do a body and X out the other.
Yes. Okay, now, because this is the quadratic formula day, you have to do the quadratic formula for all the problems, okay? Which is why we're using a calculator. All right, so just as a little reminder to myself, I'm going to just write my formula up here. Plus or minus b squared minus 4ac all over 2a. Okay, I chose to write it separately. You could choose to write it together. So I'm going to look at my problem here. So A is 1, B is -6, and C is 9. Right? Those are the coefficients. Okay, so now comes time for the calculator. Okay, because we're not focusing on the arithmetic today. We're going to learn something. So right here, x equals opposite b. Okay, so that's a +6. Plus or minus all over 2a, which is 2. Okay, see that? I left the discriminant piece out because that's the part that actually requires multiplication and subtraction. So I'm going to come here with my calculator, and I'm going to type it in. Okay, b squared. So -6 squared minus 4ac. Now, in my head, I'm like 36 minus 36 is 0. Yeah, 0. The discriminant is 0. See that? 0. I recorded it over here. Okay, continue simplifying. Okay, so we get x equals, what's the square root of 0? 0. Okay, so with that plus or minus, you might have to split it up into two things. You might also be able to do it in your head. 6 plus 0 over 2 is 3. 6 minus 0 over 2 is 3. Pretty nifty. You should get the same answer, guys. Okay, so you are to pick one of the first 3 solving methods, your choice, choose wisely, and you have to do the quadratic formula, okay? Because I want you to learn how the quadratic formula relates to these other methods and some of the solutions, okay? In Algebra 1, they just said use it. Now we're going to analyze with it. Okay, as you are working, I will come back and fill in a couple more rows, okay? Go to. All right. So, row number 2. I'm not going to isolate, but I am going to try to factor, multiply to 36. Okay, so when I get the same number, that means it's a perfect square trinomial. Okay, so here you go. I am going to skip straight to the factors. Okay, and then each factor equal to 0. Add 3, divide by 2. And I actually get the same thing twice. Okay, so I have this. Now I'm going to come over here and do my quadratic formula. A equals 4. B equals -12. C equals 9. So x equals opposite b plus or minus. The discriminant is 0. All over 2a, which is 8. So I end up with 12 over 8, okay, which is reducing by 4, 3 over 2. Oh, the same answer. Okay, so this one, multiply to 16 and add to 8. Notice how I got the same number? So it ends up being the same factor, okay? So this time I get 4x plus 1, 4x plus 1. Okay, I set the factor to 0, and we get x equals -1 over 4. Twice. All right. A equals 16. B equals 8, and C equals 1. X equals opposite B plus or minus, my discriminant is 0, over 2A, which is 32. So I end up with reducing 1/4. Da, 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 da. Okay, now time for the conclusion, right? This is the part that is a little more than Algebra 1. Okay, so on this particular page, we got a discriminant of 0. Now, I'm going to just write down the quadratic formula here just so that I have it intact. Plus or minus b squared minus 4ac. And I'm just going to highlight the part of this thing that is the discriminant. So this is the part that's 0, right? Every question on this page had a discriminant of 0, which goes in that spot on the quadratic formula. So now what I want is a conclusion. What can you tell me about the factors? What can you tell me about the factors on this page?
When the discriminant is 0, the factors are equal to each other.
Okay, so we have the same factors, right? I have the same factor twice here. Okay, so now, same factors, so we have 1. We call this a double solution because I got the same answer twice. So, right, what are we doing that's different from the past is we are now looking at connections and we are describing with vocab. All right, now I'm going to give you one more vocab word here. This is a double solution because it shows up twice. Like we saw up here, plus 0 minus 0, plus 0 minus 0, plus 0 minus 0. So it's the same number twice. We call this rational because it's a ratio of integers. So there's my conclusion. When the discriminant is 0, this part of the quadratic formula is 0. So that tells me that I get the same factor, right, twice. Same factor twice. I get one double solution. Notice how we got the same number, but we got it twice, okay? And this solution is called rational because it's a ratio of integers. All right, next page. I'm just going to do one of the problems, okay? All right, so I'm not isolating on any of these. I'm not going to complete the square, so just in case you have, all of them should factor. You need to try really hard to get the factoring done. So multiply to 56 and add to 30. 2 and 28. Okay, so yes, it factors. X plus 8. So I'm going to do my factors. 7x and x, and 4 and 2, and plus and plus. Okay. So we get x equals negative 2 over 7 and negative 4. Whew. Okay. Yes, I'm going to do the quadratic formula. A equals 7, B equals 30, and C equals 8. Oh boy. Opposite B plus or minus 676 all over 2A, which is 14. Now magically, I'm going to press the square root button in my calculator. Here, I got you. There you go. A little better. Okay. 676 is actually a perfect square. Does it come down to 24? Yeah, okay. As you can't stop there. You see how those things are like all numbers? They're like terms. You actually need to add them up. All right, so we're going to do negative 30 plus 24 over 14 equals, I'm a little bit out of space here, so I'm going to do my best. 26. I did the wrong square root. It's a 26. So sorry. 26. Okay, 26. Okay, maybe I'll come over here and I'll do the work because I need a little more space. Okay, so negative 30 plus 26 over 14. So that's negative 4 over 14 is negative 2 over 7. Okay. Negative 30 minus 26 over 14 is negative 56 over 14 is negative 4. Woo! Okay, guys, you should be getting the same answer. Now, you should maybe be recognizing that the quadratic formula, however easy or mundane it is to plug and chug, is not very fun. You should not be relying on the quadratic formula. It's these other methods that you should be focusing on. Okay, but notice you should be getting the same answers. All right, so my discriminant here is 676. My discriminant here is 121 and 289. All right, so the discriminant is something. What can you tell me about the factors? Okay. What can we say about the solutions? And that's what we will come back and write in after I check to make sure everyone's finished the other 2 rows. So on page number 2, all of these problems actually factor. Okay, 21 equals 0. You just have to be a little careful here. Multiply 42, 14, and plus. Okay, so we end up with x equals minus 3/2 and negative 7. Okay, this problem also factors. Okay, and it factors 2x, x. So it's actually the same numbers, but different pluses and minuses. So this is minus and this one's plus. And so we end up with negative 3/2 and 7. Okay, so you can do the quadratic formula. It just gets a little, tedious. Okay, so I'm going to fill in the quadratic formula. All right, so A equals 2, and B equals 17, and C equals 21. So opposite B plus or minus all over 2A. Well, I noticed that the square root of 121 is a perfect square, so it's 11, negative 17 over 4. So you might need to split that up because they're all like terms. So x equals, I'm just using this box because I needed a little bit more space. Okay, so negative 17 plus 11. Is that negative 6 over 4? Oh, how convenient. That's minus 3 over 2. Okay, x equals negative 17 minus 11, so that's negative 28 over 4. And that's negative 7. I should get the same answers. Okay, so A equals 2, B equals negative 11, C equals negative 21. Okay, x equals opposite B plus or minus 289 over 4. Okay, 289 is a perfect square. Hold on. 17? right? Is it 17? Yeah. Okay, so x equals 11 plus or minus 17 over 4. They're all like terms. They're not radicals. You got to add them up. X equals 11 plus 17 over 4. So that's 28 over 4. That's a 7. 11 minus 17 over 4. That's negative 6 over 4. That's negative 3 over 2. Woo! Okay, notice that the quadratic formula is a lot of arithmetic. Made easier from the calculator, but it's still a lot of arithmetic. So what we're going to do is we're going to look at this work, okay? Mostly this column here. And if the discriminant is a perfect square, 676, 121, 289. If the discriminant is a perfect square, right, I'm just writing down my quadratic formula here. B squared minus 4AC. Okay. If the discriminant is a perfect square, what happens to the solving? Okay, what happens to the factors? You don't get the same factor, you get two different factors. What happens to the answers? I don't get the same answer, I get two different answers. Negative 2 over 7, negative 4, minus 3 halves, minus 7, minus 3 halves, positive 7. I get two different solutions. Okay, are they rational answers? Yes, rational. Okay, because ratio of integers. Notice that this radical, right, would simplify completely because you put a perfect square inside of it. Which means when you're doing that quadratic formula, there's no radical left. Rational means ratio, means fraction, of integers. Look at how you simplified. You got a fraction with integers. That means rational.